My name is Brandon McGee, and I'm going to go over the physics of climate change. So to start off, you're probably wondering, what is climate? So generally speaking, the climate is the sum of the weather, or you can also call it the average of weather in a particular area for like a long period of time or an extended period of time. Which the climate is always slowly changing, and generally right now our climate is heating up throughout the years due to global warming. And this is all affected by many factors, which I'll be going over. So the main things that kind of make our climate is going to be a mix of volcanoes, tilt, which is the tilt of the earth, greenhouse gases, and then also oceans and large bodies of water. So to start off with volcanoes. So volcanoes let off three different things mainly, which is going to be ashes, sulfur, and greenhouse gases. Now, ashes, the first thing that they do is they create a big cloud, which you can see in this bottom right picture. Now, clouds, what they do is they block the solar radiation coming from the sun from hitting the earth. So this creates a cooling effect because that solar radiation is not able to hit the earth and create thermal radiation. So this creates a cooling effect. Now, there are mainly two different types of ashes. The first is going to be the large ashes. Large ashes do block a lot of the solar radiation, but they do not stay floating in the air very long. They're too large and too heavy to reach up to the stratosphere without falling down too fast. So they're usually in the air for about a couple hours to maybe a day. Now, small ashes are going to be very small particles. They're going to float up to the stratosphere and suspend up there for a while. They can be up there from months to a year, but they generally will wind up falling down because they cluster together. And all of these create a cooling effect and block the solar radiation from hitting the earth. Now, much like the ashes, the sulfur coming from the volcanoes does about the same thing. It does have a cooling effect because it also blocks the solar radiation from hitting the earth. And the way that it does this, it creates aerosols. Now these aerosols create droplets, almost like a film that solar radiation cannot go through. So if you can see in the bottom right picture, it has a little bit of ash cloud, but that little yellow brownish tint is going to be the sulfur that's floating in the air, which is creating the aerosols. Now, sulfur can suspend in the air a lot longer than the small ash particles. They can suspend in the air for about 2 to 3 years. So that's a very long time for them to stay up there to create a cooling effect. Now, they don't only just cool right next to a volcano. Wherever those clouds float, wherever the wind's blowing them, is what they're going to be able to cool. Now, the last thing that volcanoes let out is a greenhouse gas. Now, the greenhouse gas effect is what's in this picture right here, which allows the sun has that solar radiation that comes down, which is considered the light, which is light because the sun is so hot. Now, it hits the surface of the earth, and that earth absorbs that visible light and lets out a thermal radiation, which is actually an infrared. Now, these greenhouse gases are able to absorb all the infrared, and what it does is it heats the lower part of the atmosphere, letting between the earth and the lower atmosphere warm up. Now, the main greenhouse gases that there are is water vapor, carbon dioxide, methane, nitrous oxide, and then the ozone. And as you can see on the right side, carbon dioxide is 81%. It makes up 81% of the greenhouse gases that are floating in the atmosphere, which is a very large number because every time we breathe, humans let out carbon dioxide, fossil fuels let out carbon dioxide. Everything that we do for energy usually creates carbon dioxide. So we have a huge effect on that carbon dioxide that's floating in our atmosphere, creating this warming effect. Now, Earth's tilt also plays a huge part in our climate. Now, humans don't really have anything to do with the tilt, but it does have a huge effect with climate. So the Earth's tilt's usually at 23.4 degrees, which the Earth is not perfectly round, so it always can tilt just a little bit differently, so it does adjust a few degrees. Now, with the bigger the tilt, so say that it went to 30 degrees, which is a very big number, but say it went to 30 degrees, it means we'd have very, very hot summers and very, very cold winters. It spreads it out between summer and winter. It makes the difference a lot bigger there. Now, if we had a smaller tilt, if we went down to 20 degrees, we'd have a very small range between summer and winter. We'd have cooler summers and milder winters. And you can see in this bottom right picture here how that Earth does have a 23.4 degree tilt. Now, large bodies of water, such as oceans, lakes, and things like that, also affect the way that the climate is. So, water does not absorb the heat or let out thermal radiation like land does. And also the currents move around cold water and warm water, so it pushes different things around, makes things either heat up or cool down, and things such as that. That is why near the coastlines, you always have like a small range between summers and winters. Summers are usually a little bit milder, cooler feeling, not extremely hot. And then the winters are not cold. They're not very cold, usually not snowing. It's very warm due to all the current moving and the way that the water absorbs the light. Now with water as well, when the light does hit the water evaporates, which creates clouds. Clouds also have a very kind of weird effect on climate. So different clouds do different things, but most clouds during the daytime, if you're like out on a cloudy day, you kind of notice that it's a lot cooler feeling. You don't have that sun beaming down on you. Now some light does pass through there during the daytime, so when it comes to nighttime, it's a lot warmer. Those clouds actually trap in what light did come during the day and make it warmer throughout the night. Now during the daytime it was keeping it cooler, but nighttime it's starting to be warmer. Now with global warming right now is the heating of the Earth, which is usually caused by the greenhouse gases. Now the main problems with these greenhouse gases or global warming is the melting of glaciers. So when the glaciers are melting, it's raising the sea levels up, which is causing big problems when it comes to flooding or the mixture of salt and water in the oceans. Now ground level ozone. So the warmer it's getting, the more ozone that's going to be on the bottom. And ozone is not good for us. Animals also are changing their migration patterns. They're doing this to stay in a lot cooler temperatures. Many animals, such as like animals in the Antarctic or like polar bears, cannot withstand warm winters or warm climates whatsoever. They're just not built for it, and a lot of them are not able to adapt fast enough to stay in that particular area, so they're generally having to start moving to where they're at or to where they're wanting to go to stay cooler. Now our death rates are actually raising because of global warming. Now they're saying by 2100 that the temperature is going to be 8 degrees Celsius higher than it is. Well, you're thinking 8 degrees, oh, I can wear a sweater this day, oh, not, this is a little different. No, it's a lot different on hot days and cold days. Death rates are going up because people's who AC goes out, if it's a very hot day, elderly people, it can wind up killing them and being a huge problem. Now, the way that we can prevent this global warming, the first off is going to be change of light. Now, all these are really going to be cutting down the carbon dioxide in the atmosphere because carbon dioxide does make up 81% of all the greenhouse gases in the atmosphere. So to change your light, this saves about 150 pounds of carbon dioxide a year. If you're changing it to like an LED, it cuts it way back. Now recycling, if you recycled, say, about half of the household items that you usually would throw away, you could save up to 2,400 pounds of carbon dioxide a year, and which is a huge number. Now, if you began to walk or bike and then cut down on your driving, or even inflate your tires, makes a huge difference. Inflating your tires to the proper inflation, the proper PSI, it can save up to 3% of your gas, your miles per gallon. So every gallon of gas, you're saving 20 pounds of carbon dioxide from going into the atmosphere. Another thing would be to adjust your thermostat. Just if you adjusted your thermostat 2 degrees in the winter, so if you made it colder in your house in the winter by 2 degrees, or if you made it warmer in your house by 2 degrees, you could save 2,000 pounds of carbon dioxide a year going into the atmosphere as well. Now, all those are going to be kind of prevention items, kind of hard to go back on. Now, the best way that we're going to be able to go back and try and get some of the carbon dioxide out of the air is to plant a tree. A tree in its lifetime saves 1 ton of carbon dioxide, which is 2,000 pounds. Now, these are all my sources, and thank you for listening to my physics of the climate change.